This section discusses hypothesis tests for one population proportion. We have discussed the sampling distribution of the sample proportion p hat. The mean of the sample proportion is the population proportion. The standard deviation of the sample proportion is the square root of p times 1 minus p divided by n. The z-score of p hat represents the relative standing of p hat. Here, z equals the sample proportion subtract p and divided by its standard deviation. If we want to test the population proportion, the null hypothesis is p equals p0. We can replace p in the z-score by p0 because this is what the null hypothesis says. The resulting z-score can be used as a test statistic for hypothesis testing on the population proportion. Now we represent how to conduct a one proportion z-test. It is used to compare the population proportion with a given constant p0. It assumes simple random samples, and both n times p0 and n times 1 minus p0 are all 5 or greater. The second assumption is used to make sure that the sample size is larger enough for the central limit theorem. To perform a hypothesis test for the population proportion, we first need to correctly identify the null and alternative hypothesis. The null hypothesis is always p equals p0. There are 3 possible alternative hypotheses. For a two-tailed test, p is not equal to p0. For a left-tailed test, p is less than p0. For a right-tailed test, p is larger than p0. Next, we need to decide on the significance level alpha. Usually, alpha equals 0.05. Occasionally, alpha equals 0.1 or 0.01. The test statistic is computed as z0 equals p hat minus p0 divided by the square root of p0 times 1 minus p0 divided by n, where n is the sample size and p hat is the sample proportion. We can draw a conclusion for the hypothesis testing problem using either the critical value approach or the p-value approach. They are similar to the one mean z-test. When using the critical value approach, we need to find critical values. How to find critical values depends on the alternative hypothesis. For two-tailed tests, the critical values are positive minus z alpha over 2. The rejection region is less than negative z alpha over 2 or larger than z alpha over 2. For left-tailed tests, the critical value is negative z alpha, and the rejection region is less than negative z alpha. For right-tailed test, the critical value is z alpha, and the rejection region is larger than z alpha. If the value of the test statistic falls in the rejection region, reject H null. Otherwise, do not reject H null. We can also draw a conclusion based on the p-value approach. We calculate p-values in different ways for different alternative hypotheses. For a two-tailed test, the p-value is the probability less than negative absolute value of z0 or larger than the absolute value of z0. For a left-tailed test, the p-value is the probability less than z0. For a right-tailed test, the p-value is the probability larger than z0. If the p-value is less than significance level alpha, we reject H null. Otherwise, we do not reject H null. Last, make sure to interpret the result of the hypothesis test. In early February 2013, Gallup conducted a national poll of 1,015 US adults that asked which country is the leading economic power in the world. One of those sampled, 538, said China. At the 5% significance level, do the data provide sufficient evidence to conclude that at the time, a majority of US adults considered China the leading economic power in the world? In this problem, we are interested in the proportion of US adults who consider China the leading economic power in the world. We need to compare this population proportion with a given number, 0.5. The null hypothesis is p equals 0.5, which means that it is not true that a majority considered China top. The alternative hypothesis is p greater than 0.5, which means that a majority considered China top. Here, we use a right-tailed test because the problem asks about the majority. Notice that the word majority indicates more than 0.5. In this problem, the sample size is n equals 1015 and x equals 538. We can see that n times p0 equals 1015 times 0.5. Clearly, this number is larger than 5. Similarly, n times 1 minus p0 is also larger than 5. The assumption of the one proportion z-test is satisfied. We can calculate the sample proportion as p hat equals x over n equals 538 divided by 1015 equals 0.53. The test statistic is z0 equals p hat minus p0 divided by the square root of p0 times 1 minus p0 over n. Here, p0 is 0.5. Plug in the numbers and do the math. The test statistic is 1.91. It is a right-tailed test with significance level 0.05. We can draw a conclusion using either the critical value approach or p-value approach. Using the critical value approach, the critical value is z alpha equals z 0.05 equals 1.645. The test statistic is larger than 1.645 and falls in the rejection region. Therefore, we reject H0. When using the p-value approach, the p-value is the probability larger than 1.91. We can find this p-value using the standard normal table. The p-value is 0.0281. It is smaller than the significance level 0.05. Therefore, we reject H0. Both approaches lead to the rejection of H0. At the 5% significance level, the data provide significant evidence to conclude that a majority of US adults considered China the leading economic power in the world.